Okay, so problem 14 from chapter 18. We're given a circuit, and we have 4 resistors in the circuit. We also have a switch, and so some of these resistors will work on the switch, and some of them will not. So we can see here if we look at it a little closer. So when we flip the switch, or let's say we leave the switch open, the current is going to travel around here. There's no reason for it to go down the middle. And so we're going to have R1, R2, and R3 active. Now if we flip the switch to A, we're going to have this come around here. It's going to come around here, but it's also going to come around this loop. And so then we have essentially everything, all of the resistors are active. And then if we switch this to B, here, we actually have this come down. It's going to bypass R3 and then come around here. So this one and this one are not active. We just have R1 and R2. And so we're asked to find what is the equivalent resistance when each of the switch positions are activated. Okay, so let's look at this. Now we can use this formula here, which is the terminal voltage of a battery, because we have a battery here. Okay, and this is internal resistance of the battery. This here is internal resistance of the battery. This is the EMF that you're given. Excuse me. We're told in the problem that there is no internal resistance, so thankfully that goes to 0. That makes things pretty easy. So now we have delta V is equal to E, right? Which also means that this is equal to IR using Ohm's law. Okay, so we have the two different formulae, right? Like delta V is equal to the difference between the EMF and IR. When this is internal resistance, we're told that there is none. So now we just have delta V is equal to IR. And so what we're going to do is we're going to take R equivalent is equal to E over I. Just rearranging these a little bit, right? So taking this down here, then we end up with this equation here, which is what we're going to use. Get rid of this so I can have more space. Okay. So we'll say R equivalent 1 is going to be when the switch is open. Let me just double check. Problem 14, we're told when the double switch is open, the current is 1 milliamp. Okay, so we're told that it's a 6-volt battery. We have 6 volts over 1 milliamp. 1 times 10 to the negative 3 amps. This gives us a value of 6,000 ohms. Okay? That's when the switch is open. Then we're told, for the next one, the switch is set to the closed position A. So it's closed up here, this way. And that's going to leave us with 1.2 milliamps. So 1.2 times 10 to the negative 3. So we're just going to repeat this a few times. This gives us 5,000 ohms. And then we have the equivalent resistance for the third position where the switch is down towards B. We actually have 2 milliamps, so 2 times 10 to the negative 3 amps. This is going to give us 3,000 ohms. So this is for open switch, this is for set to A, and this is for set to B. Okay, that's pretty straightforward. Now, so we found the equivalent resistances of the system when the switches are in 3 different positions. But now, ultimately, what we're asked to find are what are the values of each of these resistors? What are the values in ohms of each of these 3 different resistors? Well, 4. I mean, this one is equivalent to this one, right? We have 2 R2s and 1 R1 and R3. So how are we going to do that? So for the first one, when the switch is open, I actually have some diagrams here. Yep, here we go. So when the switch is open, this is what we have, right? This is just going around this way, so it's just activating Req is equal to R1 plus R2 plus R3. Right? We have 1, 2, 3. Okay? That's useful. We'll come back to that. For the next part where it's open to A. Now we have, by the way, this is equal to 6,000 ohms. That's useful. Okay, so next when we go here, we have Req2. Req equivalent to, it's going to be equal to, this is in series, we can sum these up in parallel, and this would be in series as well. So what we have is R1 plus 1 over R2 plus 1 over R2 inverse, because I'm summing these up in parallel as we did before, right? These are parallel, so I'm summing them up in parallel. This would be R2 equivalent plus R3. Okay, so that's going to equal R1 plus R3 plus R2 over 2. This becomes 2 over R2, and it's inverse, so it's R2 over 2. That's equal to 5,000 ohms. And for the last one, we're going to have Req3. This is when it's set down to the position B, where it bypasses this third resistor here, and it just goes in this loop. It also bypasses this one, so these two are not active, just these two are active. And they're both in series. So what that's going to give us is R1 plus R2. So now we have 3 equations and 3 unknowns. Right, this is equal to, what was the value? It was 3,000 ohms. Remember, because we had R equivalent 3, we're summing up the resistors, but we also found the total resistance of the system. So now, going back to 1, we had R1 plus R2 plus R3 is equal to 6,000 ohms. Then we had R1 plus R3 plus R2 over 2 is equal to 5,000 ohms. So here are our 3 equations, and R1, R2, and R3 are our 3 unknowns. Okay, so we can just get rid of these. Now we solve. So we have R1 is equal to 3,000 ohms minus R2. Okay, then we plug that into 6,000 ohms. Plug it into the next equation. 6,000 ohms is equal to 3,000 ohms minus R2 plus R2 plus R3. Well, these cancel, minus R2 plus R2. We're left with, excuse me, 3,000 ohms plus R3, which means that 3,000 ohms, taking it to the other side, is equal to R3. So that's the value of R3. So we just found one. That's good. Next one. Okay, we want to plug in to the next equation. 5,000 ohms is equal to 3,000, because we're just revisiting, we have R1 plus R3. We know what these are, or we have them in terms of something else at least. So we have 3,000 ohms minus R2 plus 3,000 ohms, which is R3, right? Plus R2 over 2. Just double checking. So yeah, we replaced this and we replaced this in terms of these two things. Then we plugged in and we found a value for R3. And now we're using those values and plugging it into the last equation. Good. So now we're left with negative 1,000 ohm, taking this plus this to the other side. Excuse me, and then we have negative R2 plus R2 over 2. Well, that would be negative 1,000 ohm is equal to negative R2 over 2. So that means that R2 is equal to 2,000 ohms. And then, so we have a value for R2 and we have a value for R3. Now let's plug these back into the very first equation here and see what we get. R1 plus 2,000 ohms is equal to, what was it? 3,000 ohms. So then R1 is equal to 1,000 ohms. So here, let's rewrite everything so that we have it. R1 is equal to 1,000 ohms. R2 is equal to 2,000 ohms. R3 is equal to 3,000 ohms. These are the values that we were looking for.